All right, greetings everyone. Welcome to the third part of the video for section 3.7, continuing on our study of rational functions here, and really dig deeper into some of the stuff we've already learned about rational functions, and also look at how the equation of a rational function is related to its graph. Okay, so let's start with this question here. So we're asked to find all intercepts and asymptotes, so both horizontal and vertical, of the rational function given below. So let's start with the asymptotes, since we've been talking about that. So for vertical asymptotes, okay, we know that that comes from looking at the denominator of a rational function and the values that make that equal to 0. So we see, because here we have the x minus 1 squared and the x plus 3 in the denominator, our vertical asymptotes will come from those. So we'll have 1 at x equals 1 and 1 at x equals negative 3. Okay, so that's what makes each of those terms there 0. And then we won't worry about this right this moment, but do notice that the x minus 1 is raised to the second power, and the x plus 3 there is raised to the first power. That's going to be important when we go to graph this, but for now, we'll just note that. All right, and then for our horizontal asymptotes, and I realize I put VI, I meant to put VA here. These are vertical asymptotes. For a horizontal asymptote, recall we have to look at the degree of both the numerator and the denominator. So notice in the numerator, we have a 2x minus 3 to the first, x plus 4 squared. And so that would give us a degree of 3 there on the top. In the denominator, we have a 2 there and a 1 here, so that would also give us a 3. So we know that the degrees are the same in the numerator and the denominator. And so what that tells us then is that the horizontal asymptote will be at the ratio, a number at the ratio of the leading terms of the numerator and the denominator. So for the numerator, we see that that leading term, or leading coefficient, excuse me, would be at 0.5. In the denominator, it would be a 1, since there's nothing here. So the ratio of those leading coefficients would be 0.5 over 1, which just equals 0.5. So a horizontal asymptote should be, I call it g of x equals 0.5 or 1/2. Okay. All right. Now let's talk about intercepts. And we'll start actually with finding the vertical intercept of the function. Okay, we know to find vertical intercepts, we do that by inputting 0 and seeing what we get for our output. So I plug in 0 for x up there. I'm just going to do that on my calculator right quick. So we have 0.5 times negative 3 times 4 squared divided by negative 1 squared. Whoops, missed the parenthesis. Squared. Times 3. And it looks like when I work that out, I get negative 8. Okay, so the vertical intercept is at 0, negative 8. Again, we just have to put in 0 and find the output. All right, now horizontal intercepts. Now we know that when we're finding horizontal intercepts, we do that by taking the function and setting it equal to 0, because we know the horizontal intercepts are where the output is 0. So if 0 equals 0.5 times 2x minus 3 times x plus 4 squared, all divided by x minus 1 squared times x plus 3. And when you first look at this, this might look a little intimidating because there's lots of x's and terms everywhere, and maybe it's not clear how we're going to go through and find the values for x that make this equal to 0. However, let us notice that this thing on the right-hand side, okay, even though it's got a whole bunch of variables and whatnot, it's just a fraction. So it's like a over b, or something like 1/2, right? Even though there's the variables there. And we have that fraction equals 0. So it's like a over b equals 0. Well, thinking about what we know about fractions, a fraction can only be equal to 0 if the numerator of the fraction is equal to 0, right? Because it doesn't matter what's in the denominator, although we can't have 0 in the denominator. If we have 0 over anything, that's going to be 0. So to solve this equation here, where we have our equation of our rational function set equal to 0, we need to take only the numerator and set it equal to 0. Okay, so let me erase some stuff here. So we would have 0.5 times 2x minus 3 times x plus 4 squared equals 0. Okay, we know that the 0.5 can't ever be 0, but we could take each of these other terms, or factors, and set them equal to 0. So 2x minus 3 equals 0, x plus 4 equals 0. From that we get x equals 3/2, and x equals -4. We solve those. So we then know that the locations of our horizontal intercepts will be at 3/2, 0, and -4, 0. Okay? And just like we noted with the denominators, the terms in the denominator, let's also look at the multiplicities of these horizontal intercepts. So notice the 2x minus 3, that's to the first power. The x plus 4 is to the second power. All right, so that may affect the shape of our graphs as well. All right, so we're ready to graph this now, but before we do this, we need one more piece of information. And this is about the behaviors of rational functions on each side of a vertical asymptote. Okay. Now we're going to look back at the graphs of our reciprocal function and reciprocal squared function to figure this out. So notice the reciprocal function could draw a vertical asymptote right here. And then the reciprocal squared, we know that the vertical asymptote is right here. And notice that with the reciprocal function, which let's also remind ourselves the formula for that is 1 over x to the first. Notice that on each side of the vertical asymptote, the tails go in opposite directions. So on the right-hand side here, we see the tail going up, and on the left-hand side, we see the tail going down. And so what this tells us, or the way this relates to graphing rational functions, is that when the degree of the factor in the denominator is odd, that relates to a particular vertical asymptote, we'll see a behavior like this one, where the tails go in the opposite direction on each side of the vertical asymptote. Now, it may not be exactly the setup that we see here, okay, where the one on the right goes up and the one on the left goes down. It could be something like what I'm drawing over here on the right, where the right one goes down and the left one goes up. Okay, that's also a possibility. But anytime that factor in the bottom is odd, this is how the graph behaves on each side of its vertical asymptote. Okay? And again, that relates to, the way to remember that is that it relates to the behavior of the reciprocal function, which is 1 over x to the first, which is an odd power. For the reciprocal squared function, notice that the tails on each side of the vertical asymptote go in the same direction. Okay, and as it says here, we get this behavior when the degree of the factor in the denominator is even, which hopefully makes sense because remember the reciprocal squared, the formula there is f of x equals 1 over x squared, so we see that our power here now is even. So anytime the power of the term relating to a vertical asymptote in the denominator is even, we get this situation where the tails go in the same direction. Now, just like with the ones above, it doesn't have to be exactly like it is for the reciprocal squared function. They could both go down. Both tails could go down like this. Okay? All right, so let's use this information along with the information we found before, and let's graph this function that we were working on. So the f of x equals 0.5 times 2x minus 3 times x plus 4 squared all over x minus 1 squared times x plus 3. And we're going to start by putting in the locations of all of our asymptotes, as well as our intercepts. So we know from what we had in the denominator, there's going to be a vertical asymptote at x equals -3, and also one at 1. We saw that our horizontal asymptote was that g of x equals 0.5. That one's going to be harder for me to draw, but I'll do my best here. Let's see if this will do it. Okay. And then we'll put in our intercepts. So we knew that there was a, let's see, horizontal intercept at -4, a vertical, or sorry, another horizontal intercept at 1.5 or 3/2 right here. And then our vertical intercept was at -8, right? Okay, so now we're going to try to draw the function of this. And unfortunately, there's no like standard way we can do this. We'll do some kind of guess and check here. So first of all, I'm going to start kind of working left to right. So I'm going to start from that first horizontal intercept at x equals -4. And I see there's the horizontal asymptote right above that. So I know that probably from that point, the function is going to come up and kind of run along that value there. And also, we see that the power on that x plus 4 is to the second. And so if we think back to what we know about polynomials, when something is raised, when a 0, or the term relating to a 0 is raised to the second power in a polynomial, that means that the graph bounces at that horizontal intercept. So what we know here is that this is going to bounce off of this -4 and then go up along the vertical asymptote there. Okay, so it does something like that. Now notice, okay, and you might be wondering, right here the graph is crossing the horizontal asymptote, which you're probably thinking, Cody, you told us that graphs can't pass horizontal asymptotes. Well, they can in the short run, so remember near 0 they can. But in the long run, so as it goes way out to the left, okay, as the graph continues on this way, it will not cross that horizontal asymptote. Okay, so that's all that's going on there. Okay. Now, to figure out what happens next, we're now going to go work from our vertical intercept down below. And we note, first of all, that this vertical asymptote, this x equals -3, that comes from this x plus 3 term here, which is raised to the first power. And we know from what we were just looking at, when it is raised to an odd power like that, that means the tails on each side must go in opposite directions. So because the one on the left there, the tail is going up, on the right here, that means our tail has to go down, which means from our vertical intercept there, the tail needs to come down and run along the vertical asymptote. Okay, doing something like this. All right, and before we figure out what happens on the other side of that vertical intercept, we're actually going to go to the other side of the vertical asymptote and work from the horizontal intercept at 3/2, which again from there, we know the graph is going to have to go up and skirt along the horizontal asymptote. And then because the term related to that horizontal asymptote or intercept is 2x minus 3 is raised to the first, again, from what we know about polynomials, that means that the graph will cut straight through that, which means it's going to come down and go along the vertical asymptote like that, which will then help us figure out what goes on the other side. Okay, so this vertical asymptote comes from this x minus 1 squared term. And because that's squared, we know the tails on each side have to go in the same direction. So on this side, the tail would also be going down. All right. You could graph this and see how it relates, how the picture we have here relates to the actual graph of this function. You'll see we're a little off, but this was the sketch. We were just doing our best. And yeah, it should look very similar. All right, that's all for now. Thank you for watching.